Let's solve problem 106 under simple stresses topic of strength of materials. The homogeneous bar shown in figure P106 is supported by a smooth pin at C and a cable that runs from A to B around the smooth peg at D. Find the stress in the cable if its diameter is 0.6 inch and the bar weighs 6,000 pounds. So, this is the figure P106 and it is supported by smooth pin at C, this one. So, it is a pin connected and a cable that runs from A to B. So, this one, from A to B around the smooth peg at D. Okay, so this is the smooth peg at point D. Okay. And then find the stress in the cable if its diameter is 0.6. So the diameter of this cable is 0.6. And then the bar weight is 6,000 pounds. Okay, so let's list down the given. Okay, so the bar weight is 6,000 pounds. This bar weight is 6,000 pounds. Okay, the cable diameter is 0.6 inch. So this cable is 0.6 inch. Okay, so what is the required? So the stress in the cable. So we need to get the stress on this cable. Okay, so this is the direction on how to solve the problem. Need to get the force P in the cable, this one, the cable, and need to get the area of the cable. Okay, since we are required to solve the stress, we need the P and the A, the area, the force and the area of a cable. So we need to get the P in terms of summation forces on or summation moment, which is easier. Okay, and then uh, on how to solve the area of the cable, we already have the diameter of the cable, so we can easily solve the area. Okay, so let's proceed to solution. Okay, so this is the illustration. We already cut the cable, so the internal force will appear. Okay, so the 6,000 pound is located at the center gravity of the bar. It is always located at the center of gravity. So this is a 5 meter, 5 meter. So the center of gravity is one in between the 5 meter, since it is a 10 meter. Then the cable diameter D is 0.6 inch. This cable. Okay, we all know that this cable and this cable has the same internal force. This since it is only connected in the smooth peg at D. Uh, since it is connected in a smooth peg at D, so there is no friction acting. So if there's no friction acting, the internal force is the same. Okay, so it is, for me, it is easier to do the summation moment at C. We all know that in that the moment in all pin connected or roller support is equal to 0. So if we do the summation moment at C, it is equal to 0. Okay, so let's do the summation moment at C. This one, it is equal to 0. Okay, so let's assume that let's consider that clockwise moment is positive and counterclockwise moment is negative. So let's do a moment at point C. Okay, so T, this one, the force T, times the perpendicular distance 5 meters, this one, T times 1, plus we need to get the vertical force of this one, the vertical force. So we since so we can get the and then multiply with the distance, the 10 meters. So the vertical force of this T is the 3, this one, the vertical 3, and then divided by the hypotenuse. Okay, multiply it by D and then times it by 10 meter. This one, 10 meter is the moment arm. So less the 6,000 pound times 5. So it is negative since we consider that counterclockwise is negative and clockwise direction is positive. So is equal to 0. So we can solve T is equal to 2957.13 pound. Okay, so we already get the force P in the cable. So we only need to get the cable, the area in the cable. So we can solve the stress. Okay, so let's get the area in the cable. Okay, so we all know that it is basic that the area of a circle is pi d squared over 4. Okay, and then direct substitution, pi is equal to 0.6, it is the diameter squared over 4. So we can get the area of 0.283 square inch. So we already get the direction. We already complied with the direction. We need only to get the stress. Okay, tapos na tong direction natin. Stress na lang ang kulang. Lahat ng kailangan natin it is already solved. The T and the area. Okay, so let's proceed to the requirements. Stress in the cable. Stress in the cable is equal to P over A. The P, it is the internal force acting on the cable. Is 1. 2. 2957.13 pound. And then, the area is 0.283 square inch. Okay. So, let's solve. 2957.13 pound divide 0.283 square inch. So, the stress in the cable is 10,458.71 pound per square inch. Okay, so we already solved the problem 106. The requirement of the stress in this one, the acting stress on this cable is 10,458.71 psi. Okay, thank you for watching. Don't forget to subscribe below and hit the bell button for new engineering tutorial videos.